This presentation provides an overview of our research into monitoring irrigation practices in greenhouses and nurseries and our efforts to improve those practices. This research is part of a 5-year study that has been funded by the USDA Specialty Crop Research Initiative, and the overall goal of this project is to use sensor networks to improve irrigation and fertilization practices in greenhouses and nurseries. The research that we're doing includes both university and on-farm research, and in this presentation I want to give you an idea of the kind of work that we are doing with our grower partners that are part of this project. Specifically, I want to talk about the work that we are doing at Evergreen Nursery, a nursery located just outside of Athens, Georgia. What we have done in this nursery is installed a wireless sensor network. In the picture on the right you can see the grower, Bill Ross, and in the red circles at the top you can see a wireless data logger, while at the bottom in the red circle you can see a rain gauge. These are part of the sensor network that we have installed in this nursery. What we are doing at Evergreen is we monitor both environmental conditions as well as substrate water content. The sensor networks that we are using consist of a data logger, as shown in the bottom right corner of this picture, and a variety of different sensors that can easily be connected to these data loggers. So the picture shows some of the sensors that we are using in this research. After the data logger takes measurements with all these different sensors, the data have to be visualized in a graphical user interface. We have a prototype user interface that has been developed by Carnegie Mellon University, as can be seen in this picture right here. This is a web-based interface, and the front page of that interface consists of an aerial picture of this greenhouse right here, and on that picture the 5 different data loggers that are present in that greenhouse are indicated using the different symbols. And by clicking on any of these data loggers in this picture, you can get detailed information about what is happening in this particular part of the greenhouse. So this data logger in the greenhouse, for example, is monitoring light levels. So the blue line in this graph is showing the light level in the greenhouse, while the red line shows the daily light integral that is calculated from the light measurements. The graphical user interface that we are using at Evergreen Nursery is shown right here. There's a commercial software package available from Decagon Devices. In this particular graph we can see the relative humidity in dark red, the temperature in light red, the light level in green, and the precipitation as blue bars. And you can see the only time that it rained during this period was on October 20th. So using this interface, a grower has easy access to environmental conditions in his or her nursery. What we are also doing at Evergreen is we are monitoring a variety of different crops. So for example, in this particular hoop house we are monitoring a lantana crop, which you can see on the right, and the gaillardia crop that is on the left in this hoop house. What we are also doing in this greenhouse is monitor irrigation and rain events using a small rain gauge that is placed in between the plants. So it will capture either rainfall or irrigation from the overhead sprinkler system that is installed in this hoop house. So this shows 2 weeks worth of data that we got from that particular setup in that hoop house. The 4 lines at the top show the substrate water content in 4 different pots inside of this hoop house, while the pink bars at the bottom indicate rain or irrigation events. Actually in this case there was no rainfall during this 2-week period, so all these pink bars at the bottom are indicative of irrigation. Initially during this period the grower was watering this crop once a day, and you can see that from these 2 red circles where you see at the bottom a pink bar indicating irrigation, and at the top you can see that the substrate water content increases in response to that irrigation. Halfway through this period, specifically starting on October 14, the grower changed irrigation from once daily to twice daily, And you can see that that results in a very different signature of irrigation events. You see that following an irrigation you have a smaller increase in substrate water content because less water is applied per irrigation, and you can see that you have two peaks that indicate increases in substrate water content on any specific day that this crop was watered. Another example that I want to talk about briefly is this hellebores crop, where we are monitoring both substrate water content as well as rainfall and irrigation. And when we look at the data that we got here from a 4-week period in this case, you can see the black line here, which is the average of 4 soil moisture sensors installed inside of this hellebores crop. The blue arrows and blue bars are rainfall events that occurred during this period, while the 2 red arrows on the right side of the graph indicate 2 irrigation events that occurred after it finally stopped raining. August was a very wet month in North Georgia, so there wasn't much irrigation needed. When we look at these data, specifically the substrate water content data, it actually turns out that looking at the change in substrate water content from one 20-minute period to the next 20-minute period can provide varied information. So the change or decrease in substrate water content is shown here in red. And what you can see is that during the rainfall events that occurred during the first 10 days of this period, every time after it rained there was a rapid decrease in substrate water content. That is indicative of water leaching out of the pots. So any spike that you see in the red line is indicative of leaching occurring from this hellebores crop. So in early September, Will Ross, the grower, needed to irrigate this crop again. And what you can see in this first irrigation event is that after this crop was irrigated, there was only a minor spike in this red line, indicating that very little leaching occurred after that irrigation. So this is the kind of signature that indicates an efficient irrigation event. When he watered again the next day, what is obvious is that there was much more leaching, because following irrigation the substrate water content decreased much more rapidly than the day before. So by looking at the change in substrate water content, a grower can easily see whether or not substantial leaching is occurring after an irrigation event. And by having this kind of information at your fingertips, it should be relatively easy to come up with more efficient irrigation practices. So the significance of our work to the nursery industry is that we are now able to provide real-time information about what is happening in the containers to growers. And by putting this information at growers' fingertips, growers will be able to improve their irrigation management, and that in turn is likely to result in better plant quality, lower water use, less leaching and runoff, and perhaps most importantly, cost savings. The next phase in this research is to not only have these data loggers monitor what is happening in a crop, but actually allowing the data loggers to turn irrigation on and off as needed. So in the spring of 2011, we hope to have the next generation of hardware available that will be able to irrigate crops when needed based on the preferences of a specific grower. So the grower can determine when they want the crop to be watered, for how long they want that crop to be watered, and after that information is entered in the software, the data logger can then automatically and autonomously irrigate these crops as needed. Hopefully we'll be able to report on the results of that next year. In closing, I would like to thank the United States Department of Agriculture Specialty Crops Research Initiative for funding this research. We also have financial support of the American Floral Endowment, and we would like to thank Decagon Devices for all of the support that we have gotten from them. Thank you.